Welcome to Algebra 2, Unit 4-6. What methods are there for solving rational equations? Okay, we've talked about rational functions. You know that it's always with the variable on the bottom. These are really useful situations. So this is how we solve them. Okay. First off, if you have a rational equation that has just a fraction on each side, think back to Algebra 1 when you solve for this. You probably are saying we would cross multiply. I want you to understand what you're actually doing when you cross multiply. You're taking this times this, but in reality what you're doing is you're taking your lowest common denominator and multiplying it by both sides. So it would be like 9x and 9x. And then what happens is the 9 cancels and the x cancels. And that's why it looks like you're just simply cross multiplying. We like to make sure at this point that you understand what you've done. So when you solve that, it would be 3x equals 9 times 4, 36. And then you divide by 3 on each side and get that x equals 12. Okay? Now, you can do the same kind of thing here, but first step always on rational equations is factor everything you can. So right here you can see that you could factor out x minus 1. And so in this case, rather than just cross multiply, I said just multiply by the lowest common denominator. It still looks like cross multiplying, but I want to make sure that you can see what happens. x minus 1, x minus 1. Now that's the lowest common denominator because that x minus 1 is in there. Okay? All you need is that extra x on that side. This cancels. This, the whole thing cancels. And what we end up with is 2x equals 6, and you're down to just solving. Okay? Divide by 2 on each side. We get x equals 3. Now plug that back into the original equation and make sure that that is equal. So we have 2 over 3 minus 1. And on this side, we have 6 over 3 squared minus 3. Okay? 3 minus 1 is 2, so we have 2 over 2 on this side. Equals 3 squared is 9, minus 3 would be 6. So those are equal. 1 equals 1. Okay, next type of problem. This one, you do the same kind of method, especially if you were looking at that one where you multiply by the lowest common denominator. First thing we do is we factor. This is all factored. Can't go any lower than x minus 2. This one's factored, x minus 4. This one, play the x game. And since there's a 1 out here, you can just think it through. What multiplies to be 8 and adds to be negative 6. If you said it has to be negative 4 and negative 2, you're absolutely correct. So that is factored form. Now, we factored, find our LCD, it would be this. Okay, so we multiplied just like we did on this one, how we took the lowest common denominator and we multiplied it by everything in the equation. Same thing here. Take your lowest common denominator, multiply it by everything. So we go x minus 4, x plus 2, x minus 4, x plus 2, and I do need you to write it down. You're going to do a lot of writing on these problems. X minus 4, x minus 2, I don't know why I was doing a plus 2. My bad. X minus 4, x minus 2. Okay, now we go to solving it. The x minus 2's will cancel. x minus 4 will cancel. And now this whole thing cancels with that whole thing. So you've eliminated your fractions. If you don't end up eliminating your fraction on that step in these problems, you know something's wrong. Now we go ahead and we bring this down. X times x minus 4, that's all that was left here, plus 1 times x minus 2 equals 2. Distribute x squared minus 4x plus x, 1 times negative 2 minus 2 equals 2. Okay? Combine our like terms. X squared, negative 4x plus x would be a minus 3x, minus 2. Now, because we have 3 terms over here, we know we want to set it to 0 because we've got a factor. So we subtract 2 from that side, subtract 2 from this side, and that could become a minus 4 equals 0. So we play the x game because there's a 1 out here. We can go straight to the answer. What two numbers would multiply to be negative 4? And, well, since it's a negative 4, we know that it's a minus and a plus, so instead of add, you'd be subtracting and get a negative 3. So if you say 2 factors that multiply to be 4, subtract to be 3, it would be 4 and 1. Make sure the 4, because it's farther from 0, matches that negative there. So minus 4 plus 1. Okay, last step is to set these equal to 0, so you know that x equals 4 and x equals negative 1. Now you're not quite done on these kind of problems. You've done everything perfectly, but because of the setup on these, it's very important that you take those answers and plug them back in and see if you have an extraneous solution. Extraneous means you've done the math correctly, but when you plug it back in, you find that it would create a not a solution. Okay, so every time you have to check these. I will show you a little bit of a shortcut on checking. So x minus 1, we plug that in, negative 1 over negative 1 minus 2 plus 1 over, anywhere there's an x, you're plugging in negative 1 minus 4 equals 2 over negative 1 squared minus 6 times negative 1 plus 8. Okay, let's work it out. Negative 1 minus 2 would be negative 3. Negative 1 over negative 3, that would become a positive 1/3. Plus, negative 1 and negative 4 would be a negative 5, so we would switch that from a plus to being a minus 1/5 equals 2 over negative 1 squared is positive 1, negative 6 and negative 1, negative 6 times negative 1 is a positive 6, plus 8. So 1 and 6 is 7, plus 8 would be 15. Okay? We need to get common denominators, that would be 15, so 1 over 3, let me just do it this way. What times 5 would be 15? It would be 3. What times 3 is 15? 5. So now we end up with 5 minus 3. Each of them over 15, and that would equal 2/15. So the negative 1 checks, it works. Now we have to check and see if 4 is an extraneous solution. When we plug in 4, we have 4 over 4 minus 2 plus 1 over 4 minus 4 equals 2 over 4 squared minus 6 times 4 plus 8. Now, 4 minus 2 is 2, 4 over 2. That's equal to 2. Plus 4 minus 4 is 0. Can we have a 0 on the bottom of a fraction? Hopefully you're saying no. So it's undefined right there. We can stop right there and say this is extraneous. That's what an extraneous means. Now I'll show you a little shortcut. You can eliminate having to check that. You would know it's extraneous if you went back to your factored form. Our factored form is x minus 2 and x minus 4. That's what we got for our lowest common denominator. Right there, you could take those and say x can never be 2, x can never be 4. And if you have that from factoring, and you just qualify that when you start, then you don't need to plug in this 4 and check it, because you can say, no, at the beginning I said that would cause extraneous. Okay? Last thing, where we can really use some of these kinds of equations. We're on a camping trip, and this happens a lot to people when they're paddling downstream, upstream, is they decide they're going to go 6 miles. They take off from their camp, they go 6 miles down, and 6 miles back. But they haven't quite calculated how long is this trip going to take. I know a lot of people that end up sleeping out on a river because they couldn't get back to their camp in time. Their paddle speed they know is roughly 4 miles per hour. So can we reason, when we go downstream, your paddle speed's going with the current. So you could add your paddle speed and your current speed. Going upstream, you go against the current, so you subtract the current speed from your paddle speed. That's what takes time. Now, if we want to know our total time, distance equals rate times time. Hopefully you've got that from science. To get time alone, distance divided by rate. To get t alone, you divide by r. So distance over rate equals your time. So downstream, our distance is 6. Our rate is p plus c. Paddle speed plus canoe speed. Now we know the p is 4, so we're going to go ahead and put that in there. Now, we add to that our time coming back upstream, 6 miles, and it's 4 minus c. Okay? Now this will equal our total time. We don't know what that total time is, so that's what we're trying to calculate out. Actually, we do know. Yes, the problem tells us that we want to spend 4 hours on the river. Okay? Sorry, I didn't have that in the initial stuff. So, first step in solving this, find my common denominator. 4 plus c, 4 minus c. My common denominator would be each of those factors. So this 4 plus c would cancel with that one. We get 6 times 4 minus c, plus 4 minus c cancels, and we get 6 times 4 plus c. And over here we could go ahead and start to multiply this. Let's box these two. Notice they're conjugates, so we know we're going to get 16 minus c squared. Okay? 6, just distribute here, 24 minus 6c plus 24 plus 6c equals, not 64, 4 times 16 would be 84. Is that right? Yeah. Minus 4c squared. Okay? Combine our like terms. Negative 6c and positive 6c will cancel out, so we get 48 equals 84 minus 4c squared. We subtract 84 from each side. We're just trying to get this c squared alone. We will end up with negative 4c squared equals 36, a negative 36. Trying to get that c squared alone, we divide by negative 4 on each side. We get 9 equals c squared. Take the square root of c squared, and we get 3 equals c. So our current speed, that's actually what we were solving for because we had the total time. We were just solving for the current speed. Our current speed is 3 miles per hour. Okay? Now you could also do this in finding your total time if you knew your speed and you had a rough idea of the current speed, which you can estimate that when you're on the side of a bank. So there you go. Come to class with questions.